Alright, let's look at multiplying radicals. So when we multiply a radical, we multiply what's outside the radical and what's inside the radical. So here we have 2 square root of 3 times 3 square root of 5. So 2 times 3 is 6, and square root of 3 times square root of 5 is square root of 15. And there's our answer. Alright, let's take a look at this one. We multiply 7 times 3 is 21, and square root of 6 times square root of 8 is square root of 48. But now we notice that square root of 48 will simplify. It has a perfect square in it. So this is 21 times square root of 16 times 3, and square root of 16 is 4. So 21 times 4 times, and then the square root, then 3 stays under the radical because it's not a perfect square. And I have a video simplifying radicals. You can watch it on how to simplify the square root of 48. So this is equal to 84 square root of 3. Alright, let's take a look at some more. We have 3 times the square root of 6 plus square root of 12. So what I'm going to do here is I'm going to distribute the 3. So I get 3 times square root of 6. So 3 square root of 6 plus 3 times square root of 12. Okay. Now the square root of 12 will simplify. So this is equal to 3 square root of 6 plus 3 times square root of 4 times 3. So this is 3 square root of 6 plus 3, and square root of 4 is 2, so times 2 times square root of 3. So this gives me 3 square root of 6 plus, and 3 times 2 is 6, square root of 3. And there's the answer. And see, we can't add these because they're not like radicals. If you want to see a video on adding radicals, I have a video called Adding and Subtracting Radicals. You can watch it. Alright, so let's take a look at this next one. I'm going to distribute the square root of 6x. So 6x times 8x, that's the square root of 48x squared, plus, and then square root of 6 times 12, square root of 6x times square root of 12xy, that's the square root of 72x squared y. Now I need to simplify these radicals. So this is 16 times 3 times x squared plus square root of 36 times 2 times x squared times y. So the square root of 16 is 4. Square root of x squared is x, and for taking the square root of these variables, we're going to assume that all variables represent positive real numbers. Okay, so square root of 16 is 4, square root of x squared is x, and 3 is not a perfect square, so it stays under the radical, plus, and then square root of 36 is 6, square root of x squared is x. 2 and y are not perfect squares, so the 2 times y stays under the radical. And there's our final answer. Alright, let's look at this one. This one we're going to use the FOIL method. This is similar to like when we had something like x plus 2 times x plus 3. multiplying binomials, we're going to work this the same way. You multiply the first, outside 3 times x is 3x, inside 2 times x is 2x, and last 2 times 3 is 6. So we would end up with x squared plus 5x plus 6. Okay. I have a video on this also, the full method. You can watch it if you're not familiar with this. So here we're going to multiply the first, so we have square root of 3 times square root of 2 is square root of 6, and then the outside square root of 3 times square root of 6 is square root of 18, inside square root of 5 times square root of 2 is square root of 10, and then the last square root of 5 times square root of 6 is square root of 30. Now 18 is has a perfect square root in it, so we need to simplify the square root of 18, and I'm not going to write out the steps like I did here in these previous examples. I'm just going to go ahead and write the answer down. So this would be square root of 6 plus, and then the square root of 18 is 3 square roots of 2 plus square root of 10 plus square root of 30. So all I did in this problem is I simplified the square root of 18 into 3 square roots of 2. That's what I did from this step to this step. And let's take a look at another one. So I'm going to use the full method. So I'm going to multiply the first, 2 square root of 2 times 3 square root of 2. So 2 times 3 is 6, and then square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2. Okay. Then I multiply the outside, so I have 2 square root of 2 times 5 square root of 7, so that's going to be plus 10 square root of 14, and then multiply the inside, negative square root of 7 times 3 square root of 2 is negative 3 square root of 14, and then the last, so negative square root of 7 times 5 square root of 7. Okay, now remember, this, it's like there's a 1 in front. Okay, it's like there's a 1 in front of that 7. So negative 1 times 5 is minus 5, and then square root of 7 times square root of 7 is square root of 49, and the square root of 49 is just 7. Anytime you're multiplying square roots and you have the same thing, like here we have, say, square root of 8 times square root of 8, that's just 8. Okay. Alright, so we have 12, and then here we can combine these two because we have a like radical, square root of 14 and square root of 14. So 10 minus 3 is 7 square root of 14 minus 35, and then 12 minus 35, that's going to be negative 23 plus 7 square root of 14, and there's our final answer. Okay, let's take a look at some more. Okay, here we have square root of 7 minus 2 times square root of 7 plus 2. Now here, if you notice, this is in the form a minus b times a plus b. And in this case, a is the square root of 7, b is 2, and this is equal to a squared minus b squared. So this would equal a squared, which is square root of 7 squared, minus 2 squared. And square root of 7 squared is just 7. That's square root of 7 times square root of 7, minus 2 squared, which is 4. So this equals 3. Alright, let's take a look at another one. This one's also in the form a minus b times a plus b. And in this problem, a is equal to square root of 3, b is the square root of 5. So this is the square root of 3 squared minus square root of 5 squared. And square root of 3 squared is 3 minus square root of 5 squared is 5. So we get negative 2 is our answer. Okay. And let's take a look at one more. Okay, once again, this is in the form a minus b times a plus b equals a squared minus b squared. So in this problem, a is equal to 2 square root of 3 and b is equal to square root of 11. So this is a squared minus b squared. So this is 2 square root of 3 squared minus square root of 11 squared. So 2 square root of 3 squared, that's going to be 2 square root of 3 times 2 square root of 3. That's going to be 4, okay, because 2 squared is 4, and square root of 3 squared is 3, minus, and square root of 11 squared is 11. So I get 12 minus 11 equals 1. And there's my answer. And that's all of multiplying radicals.